everybody. Video number 8, rolling right along. Today we're going to get right into the titration calculations, which is the last piece for the lab. So we're going to use a neutralization reaction. We're just going to set that up in a controlled place so we can perform this calculation. So we can find the concentration of an unknown acid or base. Okay, so first things first. What this titration thing really is. If I know the concentration of a base and can detect when the pH is neutral, that is using the indicator phenolphthalein, you can add the base to an acid carefully and find out how concentrated the acid was. And it takes a little bit of measuring, and when I'm done with the measuring, I will be able to run it through a calculation. So notice in the picture, and I believe the picture is in your notes, that I know the volume of the acid. All right, let me go back. And then I use this special thing called a titrator, and I don't have it in my hand right now, but I will for the lab, and I'll have a video to show you how to do it. But you can see that in the burette, I put the base, NaOH, and I know how much acid I put into the Erlenmeyer, and I have an initial reading of the base, and when the reaction turns pink, I stop, and I have a final volume of the base, so I can do a little bit of a subtraction right there, and now I know the volume of the base added. So you know the volume of the acid, you know the volume of the base, and your teacher tells you the concentration of the base going in, and I use that to find the concentration of the acid. Okay, so here it is. So I'm going to add a base that it has a known concentration to an acid with an unknown concentration. That known concentration right there, you should circle that because you need that variable to plug into the equation. I'm going to measure the amount of acid to be titrated. That'll be beforehand. I'm going to measure it with a graduated cylinder. So then I know that volume. So there's a volume I know, and then I'm going to measure the amount of base that is added. So that's going to be the second volume. So I have a volume of a base, a volume of the acid, and a concentration of an acid. Then I use the titration calculation, the equation, to figure out now the molarity or concentration of the unknown acid. That's simple. It's plug and chug from there. So the results of a titration. Number 1. I will know the volume of the base that comes from the burette and be subtracting the final and the initial volumes. I will know the concentration of the base that will be given to you by me, the teacher. Okay, you will know the volume of the acid because you measured out a specific volume of the acid. I'm going to probably tell you to measure out 10 mils of acid. It makes life easy for the calculations. And then we plug and chug, solve for the concentration of the acid. Let us show you what this equation is so we understand what this whole plug and chug is all about. Here is the titration equation. This is what is in your reference tables. We call it MAVA equals MBVB. There's another, I'm not going to get into the multiple uses for this, but it is actually used for more than just titrations. All right. Notice your variables are out there. Capital M is molarity of acid, H+. You need to make that connection. H+ is acid, A stands for acid. Volume of acid, molarity of OH-, which is base. OH- means base, volume of base. So B means base, okay? So we're gonna read a problem, we're gonna plug the pieces in, we're gonna plug in chug, and we're done and this video is over. Ready? So what is the concentration of a solution of HI? HI is acid, starts with an H, so I don't know that. It's asking me what it is, okay? And it says if 0.5 liters, okay, 0.5 liters of acid, so it's volume of acid, is neutralized, because we know that acid plus a base is neutralization reaction, by 0.3 liters of KOH. 0.3 liters is the volume of the base. Notice these things don't just go right in an order. Part of the hang up of the reading comp is to put the right thing in the right place. So that's why we're going through this one very carefully. You can't just tell me they have to be in the same order every time. You need to be able to think and move and put things in the right place based on reading, okay? Of 0.4 capital M is molar, okay? So 0.4 molar concentration of base. So that is the molarity of the base is 0.4. From there, I've got everything I need, and it's plug and chug. So first, the equation, MAVA equals MBVB. Okay, I used little a's and little b's. It's okay. They don't need to be capitalized. I got X for MA. I got 0.5 for VA. I have 0.4 for MB and 0.3 for VB, and I'm multiplying these guys together. Okay, so how do I get x by itself? I need to divide by 0.5, and what I do to one side, I do to the other. When I divide that side by 0.5, the 0.5s cancels, which is brilliant, leaves me with just x. And then when I plug that other numbers into my calculator, I get 0.24. That's what you should get. Remember, it's 0.4 times 0.3 equals divide by 0.5. Can't just go 0.4 times 0.3 divided by 0.5. The computer is going to think that that is 0.3 divided by 0.5 and then multiply by 4, and then you're going to get a wacky answer. It doesn't know order of operations, right? So solve your numerator first, then divide, and you'll be all set. And with that, I think we are done. Success. There's a bunch of these equations for you to practice. Make sure you do them. Check your work with me, and then you can be on to your acid-base titration video or lab. All right.